You know that feeling, right? You flip a light switch and bam, the darkness just rushes in. It feels instantaneous, almost like it's, I don't know, faster than the light that was just there. Well, today, we're going to dive deep into that feeling and solve that exact puzzle. What is the speed of dark? And trust me, the answer might just change the way you look at shadows forever.
So let's just get right to it. The big question. Is darkness faster than light? It seems like a simple, almost childlike question, but the answer is surprisingly deep. It actually challenges the way we think about light and shadow and speed itself. And to figure it out, we've got to start with our very first clue.
And our first clue is all about understanding what we're even trying to measure. I mean, before we can put a stopwatch on darkness, we have to agree on what it actually is. And well, it turns out it's probably not what you think it is.
Here's the thing. Scientifically, darkness isn't a thing at all. It's not some kind of substance or a wave traveling through space. It is, quite simply, the absence of light. It's the state of things when there are no photons, those little particles of light, hitting your eyes. And wrapping your head around this idea, well, that's the absolute key to solving our puzzle. So, let's break it down like this. Light is a physical presence. It's made of actual particles, photons, that are physically moving, traveling from one place to another. Darkness, on the other hand, is a physical absence. It's just the lack of those particles. So because it's not actually a thing, it doesn't travel in the way we think of it. It's not in some cosmic race against light.
Okay, so if darkness doesn't even travel, then what in the world are we measuring? Well, to answer that, we need to bring in our benchmark. You know, the ultimate speed limit in the entire universe. We need to talk about the speed of light.
There it is, just shy of 300 million meters per second in a vacuum. This isn't just a really fast number, it's a fundamental constant of our universe. We call it c. Nothing with mass can ever reach it, and no information, no physical presence, can travel faster than this. This is the absolute, unbreakable speed limit, period.
All right, now let's put our two big ideas together. We know darkness is just an absence, and we know light has this incredible maximum speed. So the question becomes, how does an absence arrive? How do we see something like a shadow move?
Let's go back to our light switch. It's the perfect example. So the bulb is on, and it's pumping out a constant stream of photons. The moment you flip that switch, it stops. Now, the very last photon that left that bulb is now hurtling towards your eye at the speed of light. The instant that final photon zips past you, poof, that's when you perceive darkness. See? The arrival of the dark is perfectly tied to the departure of the light.
So here's the big takeaway from that. The edge of a shadow, that line between light and dark, it effectively moves at the speed of light. It's not that darkness is racing to fill a space. Nope. It's that the light is stopping. And that stop, that edge, propagates at light speed.
Now, I get it. This might still feel a little abstract. So let's scale it up. Like way up. We can actually see this whole principle proven during one of the most dramatic events you can witness, a total solar eclipse.
During an eclipse, the moon's shadow literally sweeps across the face of the Earth. If you were on the ground, you could clock that shadow moving at something like 2,000 kilometers per hour. But, and here's the mind-bending part, that's not the real speed of the darkness. That's just what it looks like because of the geometry of these two massive, moving, rotating bodies. The actual physical event, the sun's light getting blocked by the moon, is creating that shadow's edge at, you guessed it, the speed of light.
So why the huge difference in speed? Well, think about it. The edge of that shadow is being created way out in space, where the very last photons from the sun are just scraping past the edge of the moon. That boundary between light and no light is traveling towards us at light speed. The slower speed we see on the ground, that's just the effect of that huge shadow crossing our curved, spinning planet at an angle. The underlying physics, though, it's exactly the same.
So after all this, after digging into what darkness really is, the universe's ultimate speed limit, and even a cosmic shadow race, we finally got all the clues we need. We're at the final answer, and it all boils down to one really simple, kind of beautiful idea.
So, is darkness faster than light? No, it's not even really in the race. In a way, the speed of darkness is the speed of light, because darkness is just an absence. And like this quote says so perfectly, an absence can only arrive as quickly as the presence before it can leave. It's a fundamental connection that once you see it, might just change how you look at every single shadow you ever see again.